All right, this is a little bit to hythloday. Now, hythloday, I think I am sympathetic with your view about fields, that they feel a little arbitrary. I was thinking of an example, like let's say it's ancient times and somebody notices, hey, when you throw a ball, it goes in a parabola. And Pythagorean comes along and goes, yeah, that's a conic section. Well, why does that do that? Well, because God created the earth. Not that a Pythagorean would say this part, but let's say I come up to be sarcastic and say, well, God created the earth. And God loves conic sections, just like Pythagoras. And maybe I'll suggest Pythagoras might be God at that point. And that's not a very good explanation. It's just sort of arbitrary. But the thing is, the ball will continue to go in the parabola. I just used this example a minute ago, so I was thinking of it with the Gary video, obviously. But anyway, it'll be a little bit arbitrary. It won't be true. And you say, now, so that's my sympathy to you. I understand fields could be something like that. Maybe saying, well, what's the electromagnetic force? How's that work? Well, at first it's in a field. That could be like, well, it's in a conic section. Could be some sort of the equivalent of, because God likes conic sections, right? God likes putting values out in space. There isn't really an explanation, in other words, sort of lacking, right? So understand that. Okay, on the other hand, though, you have the concept space. You've said many times that it's just putting these values. I agree, and you can see that through the history of science, where, the earliest ideas of field is just as a mathematical thing. People weren't saying there was real fields in reality, but you still had temperature gradients, and that's basically mathematically like a field. You have pressure at each point in a liquid. There's a pressure value. These are like fields that can be treated mathematically with multidimensional shapes, three-dimensional surfaces and whatnot. And you can view that volume as a field in which these three-dimensional shapes form, right? High pressure. For example, let's say you blow some dynamite underwater. There'd be a big pressure wave going out, okay, and the volume is like the field. And there's a sphere in there, an expanding sphere, that is a high pressure point in the field. A pattern in that field, right? Arbitrary. But you keep using the word space. And so my question is, look, space, that is what the idea is. The idea of space is that there's something in it, whether it's a field, whether things are flying around in it. Our concept of space involves that. And even if you abstract that, as we had for quite a while, and thought, well, there could be a perfect vacuum, and the space can be totally empty. And I thought for years, well, is it a thing then? And yes, it is. Why? Because there is a measurability to it, namely distance. This space fits a ruler. This space fits an elephant. So even if it's empty, the fact that it would fit an elephant relates it to its ability to be full of something. So if you agree that 2 points can be separated, then of course they're going to be parameters. Now, at that point, we're talking about the materiality of the field. Well, I think, again, that people say a lot of silly things about that. Certainly, for example, we visualize the electric and magnetic field as vectors. So at a point, there's a little vector pointing in a particular direction, and it causes a reaction of a vector at 90 degrees in another field to go off, because they're really the same field, the electromagnetic field. So that's weird, because they're really not two fields at all. They're one field, and yet they've got arrows pointed in two directions, and what the fuck's going on? Who knows exactly? But there's not little arrows pointing around. The direction of the arrows is arbitrary. Just like whether the electron's called negative or called positive and vice versa, doesn't matter, but they have opposite charge, whatever you call them, right? You can call them whatever you want. Okay, the fields are not full of little arrows and things, but there's some phenomena going on. In the fact that using the field as a mathematical thing does demonstrate something. So, for example, using that field kind of mathematics in studying, pressure waves in water, right? You see an actual phenomena. You see what's going on in the water. So there's got to be something about the fact that there is different pressure values at different points, right? That's already going on. That's what we're seeing. So A field is just more abstract than saying things are flying around in space, which is actually harder to explain on a low fundamental level. We're saying, well, you know what? Something's in this space that we can imprint patterns on, patterns known as energy and material and whatnot, interactions and exchanges in chemistry and quantum mechanics, right? And we're just calling that a field. So yeah, that seems arbitrary, but unless you don't believe in space, unless you don't believe things can exist in space, yeah, you need some word. It could be the French word for it or the English word, or we can make up a new word. But basically, it's just the concept that in space, things are spread out. You don't just have to have one pressure value in the universe because there's space, and one pressure could be over there and one pressure could be over here. The idea of saying that these fields like the electromagnetic field are material has to do with there doesn't seem to be any other medium because of the Michelson-Morley experiment. There is no ether. There's no classical medium. Another way of putting it is, yeah, there's a medium. This electromagnetic field is the medium, but it's at rest to everybody. It's at rest to me, and you're in a jet going over me at 600 miles an hour or whatever they fly at, and it's at rest with you too. So that's where the weirdness comes in. You know, there's definitely we've found some weirdness. I know we've agreed on that. So anyway, that's not an argument. This is meant to be more of a question. I'm sure it sounded argumentative. I notice I tend to do that, but that's really just to dig into the point of the question, which is, hey, you accept space, and I'm saying by accepting space, you accept field as a word that describes space. How the material thing really relates to it, okay, we don't know, but where calling it a field is accurate is it makes it an attribute of space. And these properties are attributes of space. It seems. At least you're accepting space, so why isn't that enough to cover the things that go in space? So anyway, all right, cheers. Nice to talk to you again. All right, maybe you and I should do a hythloday hangout. Okay, cheers.